Hello students, welcome to the online series of math classes. We are currently doing chapter 2 relations and functions. Here we are dealing with Cartesian product of sets. In that we have dealt with Cartesian product of sets. What is a Cartesian product? We have dealt with various remarks. Now we shall do with exercise 2.1. Exercise 2.1. First question, if x by 3 plus 1 comma y minus 2 by 3 equal to 5 by 3 comma 1 by 3. Find the values of x and y. So in the theory part we learned that if two ordered pairs a comma b and is equal to x comma y then what is equal? The corresponding elements are equal, means first element is equal to the first element, second element is equal to the second element. So by that condition what should be equal to what? So this is the first element here. First element should be equal to the first element. So what you should get, x by 3 plus 1 should be equal to 5 by 3. Correct? Next, which is the next condition? Second element is what? Y minus 2 by 3. Y minus 2 by 3 should be equal to the second element in the second pair 1 by 3. So we got this. Next what we do? Take LCM on the left side. When you take LCM, x plus here cross multiply, x plus 3 equal to 5 by 3. 3 and 3 will cancel, x plus 3 equal to 5. So x plus 3 equal to 5 means x equal to 5 minus 3, x equal to 2. So next y minus 2 by 3 equal to 1 by 3 is there. Take LCM. So cross multiply, 3y minus 2 equal to 1 by 3. So 3 and 3 will cancel. 3y minus 2 equal to 1. So what you get? 3y equal to 3. So y equal to 1. So this is the value which you get. So we equate the corresponding first element and corresponding second element. Then we solve. So the solution goes like this. Ordered pairs are equal, therefore corresponding elements should be equal. Then corresponding elements are equal. Then solving we get x plus 3 equal to 5 and 3y minus 2 equal to 1 by taking LCM and adding, just like we did just now. So therefore we get x equal to 5 minus 3 is 2, 3y equal to 3, therefore y equal to 1. So this is the answer. Okay, next second question. If the set A has 3 elements and set B equal to 3, 4, 5, find the number of elements in A cross B. So we have seen the note. If number of elements in A equal to P and if number of elements in Q B equal to Q, then number of elements in A cross B equal to number of elements in A cross B equal to P into Q. P into Q. P Q. So what is the meaning? Number of elements in A cross B is number of elements in A into number of elements in Q. Number of elements in A into number of elements in Q. So set A has 3 elements. So n of A has 3 elements. 3 elements. Number of elements in B. So B has how many elements? 1, 2, 3. So 3, 4, 5, 1, 2, 3. So there are 3 elements. So n of B is also equal to 3. So how many elements are there in A cross B? 3 into 3, we have 9 elements. So this is the solution. So set A has 3 elements, set B has also 3 elements. So number of elements in A cross B is number of elements in A into number of elements in B. So 3 into 3 it is 9. Number of elements in A cross B equal to 9. Third question, important question for 1 mark. If capital G equal to 7, 8 and capital H equal to 5, 4, 2, find G cross H. Now here they have asked G cross H and H cross G. So what is G cross H? G cross H is nothing but all the ordered pairs, set of all ordered pairs where first element comes from the first set and second element comes from the second set. So here G cross H means first element should come from G, second element should come from H. Okay. So I will start G cross H. So the first element should come from G. So 7. Second element should come from H. So 7, 5. Next, the first element from the first set. So 7, 4. Next, first element from the first set. So 7, comma, second element from the second set, 7, comma, 2. Next, we can get first element from G, so 8, second element from H, 8, comma, 5. Then we can get 8, comma, 4. Then we can get 8, comma, 2. So this is nothing but G cross H, where first element is from the first set G, second element is from the second set H. Now what will be H cross G? What will be H cross G? In H cross G, first element is from the set H. First element is from the set H. Second element will be from the set G here. So what is H cross G? It is the set of all ordered pairs. So first element from second set, so 5. Second element from G, so 5, comma, 7. Then 5, comma, 8. Next, which elements are there? Next, 4, comma, 7 and 4, comma, 8. Next, first element from H, so 2, 2, comma, 7 and 2, comma. So these are the elements in H cross G. So here basically the order matters. Okay, G cross H means first element from G and second element from H. H cross G means first element from H and second element from G. So this is the G cross H and H cross G. Important one more question. Hope you have understood. Okay, so the solution goes like this: G equal to 7, 8 and H equal to 5, 4, 2. Cartesian product is P cross Q, where first element from the first set and second element from second set. So therefore G cross H will be 7, all the elements from first set 7, 7, 5, 7, 4, 7, 2. Then 8, 5, 8, 4 and 8, H cross G will be first element from the set H. So 5, 7, 5, 8, then 4, 7, 4, 8, then 2, 7 and 2, 8. So this is the next fourth question. State whether each of the following statements are true or false. If the statements are false, rewrite the given statement correctly. If P equal to M, N and Q equal to N, N, P cross Q equal to M, N and N, N. Is it true or false? Okay, so let us find the correct answer. P cross Q means, what does P cross Q contain? P cross Q contains set of all ordered pairs, so it is a set containing all ordered pairs. What are the ordered pairs? Ordered pairs, first element from the first set and second element from second set. So P is the first set and Q is the second set. So take first element from first set, so M, comma, second element from second set, so M, N. Then what is the next one? We have M from the first set and here again M from the second set. Next which set is possible? Next which pairs are possible? N from the first set and M from the second set. Then N from the first set and M from the second set. So this is nothing but the P cross Q. Now here what P cross Q is here? Here only 2 elements are given. This is not true. This is not true because there are 4 elements in P cross Q. Okay, there are 4 elements in P. So this is false. So this is false. So this is the correct answer. Also by direct you can verify, since there are 2 elements here, there are 2 elements here. Number of elements in P cross Q should be 2 into 2, 4. So since here only 2 elements are there, you can directly tell this is false. Okay. Next to second one, if A and B are non-empty set, A cross B is a non-empty set of ordered pairs x, y such that the first element x belongs to A and second element y belongs to the second set B. So this is definitely true. This is by definition. Next third point, if A equal to 1, 2, B equal to 3, 4, A cross B intersection 5 equal to empty. Is it true or false? Now we know that B intersection 5. B intersection 5 means common between B intersection 5 is always a empty set. B intersection 5 is always empty set because there is nothing common between the set and empty set. There is no element common. So therefore B intersection 5 equal to empty. So therefore what we get, A cross 5 is empty. So this is from note number 3 which we have. So A cross empty set is always empty because I told you when you're taking empty set, first element from first set and second element from nothing, there is no element to pair, so there are no elements. So this is also true. Okay, so these are the solutions. First solution is this, second one is true, third one is also. Okay, so we shall move on to the next question. If A cross B equal to A comma X comma A comma Y, B comma X and B comma Y, find A and B. Now here look at the order. A cross B is given. A cross B means what? First element should belong to the first set. Second element belong to the second set. Here also first element should belong to the first set and second element should belong to the second set. Here also first element from first set and second element from second set. First element from first set and second element from second set. So that is the definition. So here first set is which one? First set is A. So which element belongs to the first set? First element. So first element is A, then here B. So these are the first elements in ordered pairs. So this is the set A. They belong to the first set A. What elements are there in the second set B? The elements which are in second position. So which are elements are there in second position? X, Y. So this is nothing but the set. So quite a simple, straightforward answer. Okay, so since first element belongs to the first set and second element belongs to the second set, the first element is A and B, so they belong to the set A. Second elements in the pair is X and Y, so they belong to the second set. That is. Seventh question: if A equal to 1, 2, B equal to 1, 2, 3, 4, C equal to 5, 6, and D equal to 5, 6, 7, 8, verify that A cross B intersection C is equal to A cross B intersection A cross C. So we have to do this. So first verify the left hand side. First verify the left hand side. So we have to get LHS. So LHS equal to A cross B intersection C. So A cross B intersection. Now what is B intersection C? B intersection C means elements common between B and C. Elements common between B and C. So what is B intersection C? Is there any element common between B and C? Is there any element common between B and C? There is no element common. So B intersection C is empty set. B intersection C is empty. So we have to take the Cartesian product of A cross empty set. What is A cross empty set? A cross empty set is always empty. So LHS is A cross empty set, it is empty. So LHS is done. What about RHS? We have to find first A cross B intersection A cross C. First find A cross B. What is A cross B? So this is A, this is B. First element from the first set and second element from the second set. So it is 1, 1, then 1, 2, then 1, 3 and 1, 4. Next which elements are possible? 2, 1, then 2, 2, then 2, 2, 3, then 2, 4. These are the elements possible. So we got A cross B. Now we have to get A cross C. We have to get A cross C. What elements are there in A cross C? So this is A, this is C. So first element from the first set, so 1, 5, second element from C, 1, 5, then 1, 6, then 1, then 2, 5 and 2, 6. So these are the elements in the Cartesian product. Now, if you take intersection between these two sets, is there any set common? Is there any element common? There are no elements common here. 1, 5, 1, 6 is not there here. 2, 5, 2, 6 is not there here. So there are no element common in both sets. There are no element common in both sets. So therefore their intersection is empty. So therefore their intersection is empty. Therefore A cross B intersection A cross B is empty set. So RHS is empty set. LHS is also empty set we got. So therefore we verify LHS equal to RHS. So the answer is verified. So A intersection B we got empty set. therefore when you took A cross B intersection is A cross empty set, it is empty set. Then A cross B is 1 comma 1 1 comma 2, this we got. A cross C we got so much, just now we got. We took the Cartesian pairs, first Cartesian pairs, first element from first set and second element from second set. Therefore when you took intersection there is nothing common, therefore this is, so it is verified. Next we have to get A cross C is the subset of B cross C. So first find A cross C. What is A cross C? First element from first set. First element from the first set and second element from second set. So we take the Cartesian pairs, we take the ordered pairs. So first element from the first set. So 1, second element from C, 1 comma 5, then 1 comma 6, then 2 comma 5 and 2 comma 6. So we took this ordered pairs. Okay, so we took the ordered pairs A comma A cross C. This is A cross C. Next we take B cross T. B cross T means first element from the first set and second element from the second. So we can take 1 comma 5, 1 comma 6, 1 comma 7, 1 comma 8, then 2 comma 5, 2 comma 6, 2 comma 7 and 2 comma 8. Then 3 comma 5, 3 comma 6, 3 comma 7, 3 comma 8. Next you can take 4 comma 5, 4 comma 6, 4 comma 7 and 4 comma 8. So these are the Cartesian pairs possible. These are the Cartesian pairs possible. We took them in the brackets. So this is B cross T. Now is A cross C a subset of B cross T? Here since the elements are there in commas, the Cartesian pairs are nothing but subset of or elements of A cross C. Now is this a subset? So for A cross C to be subset of B cross T, all the elements of A cross C should be there in the bigger set, correct? All the elements of A cross C should be there in the bigger set. Now is this there? So 1 comma 5, 1 comma 5 element is there here. 1 comma 6, 1 comma 6 element is there in this. 2 comma 5, 2 comma 5 is there in this. 2 comma 6 and 2 comma 6 elements are there. So therefore all the elements of A cross C are there in the bigger set B cross C. So by the definition of subset, if A is a subset of B, if all the elements of A are there in B, here all the elements of A cross C are there in B cross T, therefore A cross C becomes the subset. Therefore, this is the answer. So we have verified that A cross C is a subset of B cross T. Next, 8th question. Let set A equal to 1, 2 and set B equal to 3, 4. Write A cross B. How many elements, how many subsets will A cross B have listed? Now, if set A is given as 1, 2, set B is given as 3, 4, we have to find A cross B. What elements are there in A cross B? So, first to find elements of A cross B, it is nothing but ordered pairs. First element from the first set and second element from the second set. So, 1, 3. Then 1, 4. Okay. Next, first element from first set. So, 2, 3 and 2, 4. Okay, so this is A cross B. So how many elements are there? So you can see there are 4 elements. Or you can get directly also. See, there are 2 elements here, there are 2 elements here. Number of elements in A cross B is number of elements in A into number of elements in B. So 2 into 2 is 4. So directly you can get number of elements equal to 4. So this is A cross B. Number of elements in A cross B equal to 4. So number of elements in A cross B equal to 4. So how many subsets will A cross B have? So how many subsets are possible for this set? So in the previous chapter, sets chapter, we know that if the number of elements of a set equal to n, then the number of subsets possible is 2 to the power n. Now since if there are 4 elements in A cross B, number of subsets possible is 2 to the power 4, which is equal to 16. So therefore 16 subsets are possible. So these are the subsets we can list them. So if I give one more example, if the set A equal to 5, 6 and 7, and if set B equal to 2 and 3. How many elements are there in A cross B? So here we have 3 elements, here we have 2 elements, so 3 into 2, we have 6 elements. We have 6 elements in A cross B. So n of A cross B is, we have 6 elements. So what are the subsets possible? How many subsets are possible? 2 to the power 6, 2 to the power 6 is 64. So 2 to the power 6, number of subsets are possible by the formula. So 64 subsets are possible. So this is the answer. So here you can list all the subsets. Now, this is the answer. The ninth question, A and B are two sets such that n of A equal to 3 and n of B equal to 2. If x comma 1, y comma 2 and z comma 1 are in A comma B, A cross B, find A and B. So we know that in the ordered pairs, first element belongs to the first set and first element belongs to first set and second element belongs to second set. So which are the element here in the first set? First set is A and second element set is B. So here first element here is A. So here first element will belong to A. So first element belongs to A. First element belongs to A and first element belongs to A. So which are the elements in A? Elements in A are X, Y and Z. Which are the elements in B? Second element belongs to set B. So set elements in set B is 1, comma. So it agrees with the given condition. So n of A is 3. So there are 3 elements. So this is correct. So n of B is 2. There are 2 elements here. So this also is 2. So this is the answer. This is the answer. So set of first elements in A cross B. First element belongs to first set. So clearly this is the element. These are the elements. Next 10th question. The Cartesian product A cross A has 9 elements, among which are the Cartesian product. These elements are found. Means these are the ordered pairs. In A cross A. So I told you earlier, in A cross A, what is A cross A? In A cross A, first element, it is the ordered pairs. First element belongs to A. Second element also belongs to A only. Second element belongs to second set, which is A only. The first element also belongs to A. Second element also belongs to A. So these are the elements given, minus 1, comma 0 and 0, comma 1. So what should happen? First element also belongs to A and second element belongs to A. First element belongs to A and second element also belongs to A. So which are the elements in A? The elements in A are nothing but minus 1, 0 and 1. Minus 1, 0 and 1. So these are the elements. So these are the elements. So number of elements in A cross A are minus 1, 0 and 1. So these are the elements in. Number of elements in A is 3. Now, which are the elements in A cross A? Which are the elements in A cross A? So find A cross A. Which are the elements in A cross A? So it is the Cartesian product of minus 1, 0 and 1, minus 1, 0 and 1 with the cross product with the minus 1, 0 and 1. So we write the ordered pairs. We write the ordered pairs. First element belongs to the first set. So minus 1. Second element belongs to second set. Minus 1, comma minus 1. Then minus 1, comma 0. Then minus 1, comma 1. Next which elements are possible? 0, comma minus 1. Then 0, comma 0. Then 0, comma 1. Next which elements are possible? 1, comma minus 1. 1, comma 0 and 1, comma 1. So these are the elements possible. So among this, minus 1, comma 0 they have given, 0, comma 1 they have given. Rest all the elements are not there, that we have to write. So this remaining elements we. So these are the remaining elements. So this is the answer. Next last question. This is one note which I had in the remarks. Fourth note. If A equal to minus 1, comma 1, find A cross A cross A. What is A cross A cross A? It is nothing but triplet. Okay, triplet. A, comma B, comma C. A, comma B, comma C. Where first element belongs to first set, second element belongs to second set, and third element belongs to the third set. So therefore, in the in the ordered pairs, first element belongs to first set, second element belongs to second set, and third element third set. So it A cross A cross A cross A cross A, it is nothing but the ordered pairs of -1, 1 cross -1, 1 cross -1, so when you take the ordered pairs, first element you have to take from the first set and second element you have to take from the second set and third element you have to take from the third set. So all the three sets are A only. So therefore we are taking all the three elements from first, second and third set. But the order differs. So we can take like this. We can take -1, then -1 and next which is possible -1, -1 and 1. Next which element is possible -1, 1 and -1. Next which element possible -1, 1 and 1. Okay. Next which element is possible? Take first element from the first set, so 1, -1, comma -1. Next which element is possible? 1, -1, 1. Next which element is possible? 1, 1, -1. Next which element is possible? 1, 1. So these are all the elements possible. These are all the elements possible. So this is nothing but A cross A. So this is nothing but A cross A. You can write sequentially, taking first element first set, second element second set, and third element from third set. Okay, this is one way to remember. If not, what you do, you write -1 and 1. Here I'll write, here I'll write. You take -1 and 1. So with -1 I can take -1 and 1. Here with 1 I can take -1 and 1. With -1 I can take again -1 and 1, or -1 and 1. So -1 and 1 I can take, -1 and 1. So which elements are possible? -1, -1, -1, -1, -1, 1. Next -1, 1, -1, -1, 1, 1, 1, -1, -1, 1, -1, 1, 1, 1, -1, 1, 1. So these are all the pairs possible. So there are two methods. We can follow the first method or we can follow the second method. Whichever method you follow does not matter. Final answer if we get it is, without confusion, we get the final answer is. So these are all the ordered pairs possible. There are two ways to get the answer. So whichever method suits you or whichever method is easy for you, out of the two methods which is easy for you, that you follow. Okay, so I hope this is understood. Here we conclude the first exercise. Hope you have understood. Thank you. So I hope you have understood. Any doubts, you can ask. We shall move on to the next topic. Thank you.